The average surface temperature in the Arctic is warming more than twice as fast as the globe as a whole. Experts suggest that there may be nearly no sea ice in the Arctic summertime by the late 2030s. That's a quick decline of a lot of ice. That means that in 2 decades, our North Pole, which we think of as white and icy, could become just an expansive dark ocean. And a dark ocean absorbs even more sunlight, warming the Earth even faster than it is now. As the Earth warms, it does not warm consistently, but the Arctic's disproportionately quick surface warming is raising questions. Our Earth is a mix of many interacting systems between the air, the water, and the land. So scientists are actively studying how melting sea ice and a warmer Arctic might affect other areas of the globe. As some scientists say, what happens in the Arctic doesn't stay in the Arctic. These are called teleconnections, changes that happen at one location of the Earth that cause resulting changes in a different geographic location. So far, scientists have found that there does appear to be a relationship between the warming in the Arctic and changing patterns in the jet stream. And that matters because the jet stream has a lot to do with the weather patterns that we experience in the United States. So, what's the jet stream again? If you've ever flown in a plane across the US, you may remember that it took less time to go west to east than east to west. That's because of the jet stream. It's essentially a river of wind that runs west to east and travels around 200 miles an hour at about 30,000 feet in altitude. Most importantly, it dramatically affects our weather. Think about the weather maps of the United States you see in the news. There's always some sort of wavy separation between the colder temperatures in the north and the warmer temperatures in the south. Those cold temperatures that you see come from a giant cold air mass dipping south from the Arctic, and the warm temperatures come from hot air moving to the north from the equator. The jet stream can be found in the atmosphere above where those two air masses meet. This is all important to note because the jet stream is what creates and moves much of our precipitation and storms in the US. Its path traces where it's raining or snowing in our country. So when you experience a big snowstorm in the winter, for example, the jet stream likely played a role in guiding the storm to you. To understand how the jet stream connects to the Arctic, we need to explore how the jet stream is formed, and also review some basic properties of air. You may remember that as air molecules heat up, they move faster, move apart, and create more pressure. So warmer air has higher pressure, and cooler air has lower pressure. Think of a car tire. On an extra cold morning in the wintertime, you might find that you have low tire pressure. That's because the air inside of your tires is cold, and therefore the molecules are moving slower and exerting less pressure on the tire. Let's apply this concept at a bigger scale. That means that warm air at the equator has more pressure than cold air at the poles. And yeah, it also means that the atmosphere at the equator is also physically taller than the atmosphere above the poles. Crazy, right? Air naturally moves from places with high pressure to places with low pressure, and when air moves from one place to another, it creates wind. So that's where our jet stream comes from. Wind created by air moving from the warm equator, where there is higher pressure, to the cold Arctic, where there is lower pressure. And the west to east nature of the jet stream occurs because the Earth is rotating west to east. But when the average air temperature in the Arctic increases disproportionately to the rest of the globe, like it is now, it changes the pressure and temperature difference between the equator and the poles. This change influences the Earth's winds and atmospheric circulation patterns, and has the potential to change the path, speed, and character of the jet stream in unprecedented ways. Because of that, it also has the potential to change the weather patterns in the United States. Scientists have already seen evidence for a potential weakening of jet stream winds, which could cause weather to get stuck, since it's not moving as fast. So, for example, in a pattern of dry weather, that stickiness could cause a drought over time. Through climate models and observations, scientists are currently studying exactly how the Arctic and the jet stream are connected. These warming Arctic temperatures that we've been talking about are just occurring in the lower atmosphere of the Arctic, and that's just one factor of many that influence the jet stream. We know that Arctic warming can influence the jet stream, and now we have to figure out if it already has influenced it, if so, in what ways, and if it will in the future. The takeaway message here is that the Earth's climate is a relatively closed system. Changes in one area of the Earth will influence other areas, whether they are close together or not. Climate scientists are working hard to keep up with the pace of our rapidly changing planet, and they'll continue to refine our understanding of the weather, the climate, and how they're changing together. Just remember, what happens in the Arctic doesn't stay in the Arctic. Thanks for watching. For more information, visit www.agci.org.